The half-life of technetium-99 metastable is 6 hours. If the compound is used 24 hours after preparation, what percent of it remains? We're talking about a first-order rate law, so let's start with our first-order rate law equations. We have our natural log times the number of nuclei at time t equal to negative k, which is the rate constant, times the time, plus the ln of the number of nuclei that there was originally. So this is the same as the integrated first order rate law that we used way back at the beginning, but instead of using the A naught, the concentration of A at time 0, we're now using the number of nuclei at time 0 instead. So the only thing we've done is substitute a different variable, and the other first order rate law equation that we are familiar with is that the half-life is equal to the natural log of 2 over the rate constant. All right, so let's take a look at our question. We have a half-life, all right, so that's this, and we have 24 hours, so we know that's time t. We want to know what percent of it remains. So that percent is referring to the ratio of this compared to this. So that's our goal. We're given the half-life and time t. From the half-life, we can find the k and substitute that in here. We have t from here, and that means the only variables that we have left are these ones that we're interested in their ratio of. So let's start by finding k. So we can rearrange this half-life equation using the half-life to find k. So now our rate law is equal to the ln of 2 over 6 hours, and that equals 0.116 inverse hours. So you can write the inverse hours like this, or I know a few you said the unit conversions were confusing, so you could write it like this to keep your units straight a little bit better. Okay, so now we have k, and we can substitute that into this original equation that we wrote with t. But first, since we want to talk about the ratio of nt to no, I think it's helpful to rearrange that first order rate law. If we first start by bringing the natural log of the number of nuclei originally over to the other side, and then this expression right here is the same thing as saying the ln of nt over ln of n naught, and then we can use the anti-natural log, which is e, over both sides, and then this e to the natural log cancels, so you're left with just nt over n naught. So this equation gives us the direct ratio of nt to n naught, which is kind of what we're looking for in this question. Then we can just plug in the variables that we calculated. So e, and we calculated k to be 0.116 inverse hours, and we know that time t was given in the question up here is 24 hours. You multiply that out, you get 0.062, and then the question asks for it as a percentage. Right now we have it as a decimal, but we can turn that into a percentage by multiplying into a percent. So this would be 6.2%. When you round for sig figs, because this one only has one significant figure, that would be 6%.